Friends, very good morning to everyone. We dealt with E2 mechanism, the one of the mechanisms which has been put forward to explain the bimolecularity of the elimination reaction. As we know that few of the alkyl halides also follows even mechanism. This has been put forward to explain the unimolecularity of few of the alkyl halides. That is, few alkyl halides follows first order kinetics. What is the mechanism of this? In this even mechanism, the halogen which is attached to the alpha carbon dissociates to give rise to a carbocation. This is the first step in the reaction and it is the slow reaction and hence it is the rate determining step. After the carbocation is formed, in the presence of a base, the proton gets abstracted from the adjacent carbon, that is the beta carbon, and that excess electron forms the bond with the adjacent carbocation and it gives rise to an alkene by elimination of hydrogen and halogen. This is the mechanism put forward to explain the unimolecularity of the alkyl halides. Here, it occurs in two steps. First step is the formation of the carbocation and it is the rate determining step. And in this rate determining step, the base is not involved. Thus, the rate of the reaction is independent upon the concentration of the base and also the strength of the base. That is, either the strength or the concentration of it do not affect the rate of the reaction. The characteristic feature is that rate of the reaction is dependent upon the concentration of only alkyl halides. That's why it is unimolecular in nature. That's why it follows first order kinetics. The characteristic nature of this even mechanism is that it follows first order kinetics. The mechanism, it involves two steps. First step is the carbocation formation, which is the rate determining step, and another the first step in which the base abstract the proton. More the substitution of the carbons by the alkyl group, faster is the reaction. That is, tertiary alkyl halides are more reactive than secondary alkyl halides are more reactive than primary. The base strength or the base concentration do not affect the rate of the reaction. More easier the leaving group, more easier the formation of the product. And it is favored by polar protic solvent, as this polar protic solvent stabilizes the carbocation form. The evidences are given in support of this two-step mechanism. In case of E2 mechanism, we have seen that it shows primary isotopic effect. But here, we do not see this primary isotopic effect. When the hydrogens in the alkyl halide is been replaced by deuterium, its heavier isotope, the rate of the reaction decreased when it followed E2 mechanism. But here the rate of the reaction is not affected when it is replaced by its heavier isotope. What it indicates, removal of proton is not the rate determining step. In turn, it indicates that carbocation is the intermediate form. In case of tertiary alkyl halides, it gives tertiary carbocation, and secondary and primary, it gives secondary and carbocations respectively. And as we know that tertiary carbocations are more stable than secondary or more stable than primary, tertiary alkyl halides are more reactive than primary. Another evidence which has been given in case of even mechanism is that it gives rearranged product. In case of E2 mechanism, as it involves the reaction in which it is a single concerted step. Hence, rearranged product was not possible. Here we can get rearranged products. Undergo neopentyl rearrangement, which we have studied at length. This is also stereoselective like that of E1 mechanism. It also follows Seitzeff's rule and it is non-stereospecific like E2. If I take E1 reaction, here it gives two products. One is the tri-substituted product, which is the major product, and here is a di-substituted product, which is the minor product. It has two beta carbons, one over here, another over here. If it gets abstracted from here, it gives a tri-substituted product. If the proton abstracts from here, it gives a di-substituted product, which is the minor product. The more substituted products predominate. That is Seitzeff's rule. And there is another mechanism which has been put forward that is called as E1CB mechanism. And the reaction as E1CB reaction. E1CB reaction occurs in alkyl halides which are having a very poor leaving group and a more acidic hydrogen. An alkyl halide having more acidic hydrogen and a poor leaving group are treated with the base, it follows E1CB mechanism. The base abstract the proton and another conjugate base is formed. This conjugate base which is formed shares that electrons with the adjacent carbon and carbon halogen bond breaks and it gives an alkene. What is this E1CB? E1CB stands for Elimination Unimolecular Conjugate Base. This is unimolecular reaction. The concentration of the substrate only affects the rate of the reaction. This conjugate base is formed from the starting material compound by the deprotonation by a suitable base. When the electron withdrawing groups are present on the carbon to which the proton is attached, the electron withdrawing groups can be a carbonyl group, which can be a keto, aldehyde, or an ester, or a nitro group, or an electron deficient aromatic group. It increases the acidity of the proton. For example, this is the carbon to which the hydrogen is attached and OH here is a poor leaving group. And here this hydrogen is acidic hydrogen. Why is this acidic? Adjacent to this carbon there is an electron withdrawing group. As it withdraws the electrons from this carbon, the positivity on this carbon increases. Means it is electron deficient. Means with less number of electrons it is holding the hydrogen. That's why the bond between this carbon and hydrogen is weak. Weaker the bond, higher the acidity of the hydrogen, more easy the removal. When I treat with this kind of compounds with a base, it abstracts the proton and it gives an anion, and this anion is stabilized by the adjacent carbonyl group or an electron withdrawing group. The pi electrons moves on to here and this pi electrons moves on to the oxygen, and there is an equilibrium existence in between these two structures. This conjugate base donates its electrons to the adjacent carbon and OH gets kicked off. This is E1CB reaction and this is E1CB mechanism. As the conjugate base is formed as an intermediate, it is called as elimination unimolecular conjugate base. The E1CB mechanism is followed by the dehydration of an aldol. Aldols, we know that it is having both aldehydic group and the alcoholic group. This is an aldol. This is hydrogen. This is an aldehydic group, and this is an alcoholic group. This is aldol. Dehydration of this aldol follows E1CB mechanism. This is all about the elimination reaction. Next class, we can meet with the next chapter. Thank you. Till then, have a nice day.